Good evening, everyone. This is IAL Chemistry, Mass Spectrometer, and Ionization Energy assignment. We have already discussed the first 13 questions. Now we'll discuss from 14 onward. Question 14, the structure question 14. This question is about the element sulfur. Complete a diagram to show the electronic structure of sulfur atom. Include a label for each subshell. So 1s is there. After 1s, it will be 2s, then 2p, then it will be 3s and 3p. And the maximum number of electron in each orbital, that is 2 with opposite spin. So when we complete this structure, 2s will have 2 electrons, one clockwise, another anti-clockwise. For 2p, first they will occupy singly. And how many electrons we have to arrange when we check the periodic table? Sulfur 16 and 32. So we have 62, we have 16 electrons, so we have to arrange 16 electrons. So 2, 4, 6, 8, 10, 12, 13, 14, 15 and 16. So we have arranged the 16 electrons. First singly in p orbital they occupy and then they will pair up. Write an equation for first ionization energy of sulfur, include the state symbol. So first ionization energy required to remove the electron from neutral gaseous atom. So sulfur in a gaseous state, we supply energy, so it will form sulfur ion. In a gaseous state by loss of electron, we call that as first ionization energy. Explain why the first ionization energy of sulfur is less than first ionization energy of both phosphorus and chlorine. So when we write the electronic configuration for each, sulfur 16, phosphorus is 15 and chlorine is 17. So it is having 15 protons, this is having 17 protons, and this is having 16 protons. When we write the electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p3. This will be 1s2, 2s2, 2p6, 3s2, 3p4. And the sulfur we already mentioned, 1s2, 2s2, 2p6, 3s2 and 3p2 will be there. 3p4, 16 we need, so this will be 4. Now the reason why the first ionization energy of a sulfur is less than for both compared to that of phosphorus as well as chlorine. So basically what happened, you can see this, they all have the same subshell. The outer shell electron is in the same subshell. But chlorine contain greater number of protons so strong attraction which result in higher ionization energy than sulfur. And what about phosphorus? Why phosphorus is having higher? Because In a 3p orbital for sulfur, there is a pair of electrons which repel each other. So electron can be removed easily from sulfur compared to phosphorus. So as you can see, because when we write the p orbital having 4 electrons. So when it is having 4 electrons, so there is a pair of electrons. First they will occupy singly, and then they will start to pair up. So there's a pair of electron, and that will have repulsion, so we can remove one of the electron easily. Where in phosphorus, there is no pairing of electron, as when these electrons are occupying their space, first they will occupy singly the p orbital, and then they pair up. So first they have less repulsion as compared to that of sulfur. So sulfur will have lower ionization energy compared to both phosphorus and chlorine. A sample of a sulfur contains 4 isotopes. What is meant by the term isotope in terms of subatomic particle? So in terms of subatomic particle, atoms of the same element with same number of proton but different number of neutrons, we call that as isotopes. Then we have to find the relative atomic mass of sulfur. So how to find the relative atomic mass of sulfur? That's percentage multiplied by mass. So 94.88 multiplied by mass 32 plus 33 multiplied by 0.83 plus 34 multiplied by 4.27 plus 36 multiplied by 0.02, and that divided by the total percentage, which is 94.88 plus 0.83 plus 4 plus 0.02. So that will be 100. So it will come out as 32, 2 decimal places, so 32.09 gram per mole. The mass spectrum of a sample of a sulfur with 32 as the only isotope is shown. Calculate the number of sulfur atoms in molecular ion. You must show your working. So how we can work out the number of sulfur atoms in a molecular ion, and it's of only 1 mark. So the maximum peak what we are getting here, the mass spectrum of a sample of a sulfur as the only isotope. So sulfur, all are sulfur 32, and we are getting 100%. This one as 100%, which is 64. So basically it is S2 with a charge of plus 1, because sulfur is 32, 32 multiplied by 2, that would be 64. So this is 32 multiplied by 2 divided by charge is plus 1, so that's why it is 64, which we are getting at 100% the relative abundance. So it is S2 molecule or SS molecule. Suggest a formula for most stable ion. So the most stable one is S2 because we have 64, and the molecular ion peak, this one 56 is there, so 56 divided by 32, so we'll get 8 sulfur atoms, because in this part they're asking for molecular ion peak, so 256 divided by 32, so it means it will have 8 atoms, because they're asking for number of in molecular ion. Molecular ion is the highest one for mass to charge ratio, and here the most stable one is S2 with a charge plus 1. Question 15. Isotopes of magnesium both forms an ion with a charge 2 plus. The following statement about these ions is true. For question 15, both ions have the electronic structure of 1s2, 2s2. So when we write because magnesium it's 12, so it loses electrons, so total it left with 10. So they don't have this electronic configuration. It should be 1s2, 2s2, 2p6. Magnesium, which is 25 and 12, has more protons, though they don't have the equal number of protons. That's also wrong. Ions have the same number of electrons but different number of neutrons. Yeah, that's true because these are the isotopes. So C is the right answer. And the last statements, ions have the same number of neutrons but different proton. That's wrong. Chlorine has two isotopes with relative isotopic mass of 35 and 37. Four mass to charge values are given, which will occur in mass spectrum of chlorine from an ion of single positive charge. Chlorine gas. So chlorine gas is actually Cl2, and we want for plus 1 because the charge is plus 1. The chlorine, the possibilities, if both of them are 35, then it will be 70. If one is 35, another one is 37, then it will be 72. And if both of them are 37, then it will be 74. So D will be the right answer. The first ionization energy in kilojoule per mole for 4 elements in a consecutive atomic numbers are shown. Which element could be inert gas? So how the one which will have the highest ionization energy, that will be inert gas, and they are consecutive, so B will be the inert gas, highest one. So it means this is group 8, then this will be group 7, then after group 8, because we'll have group 1 and then we'll have group 2. Which element could be X in a covalent compound with a formula? So it means it's a group 7 element, so which is group 7? A is a group 7. Which element could be Y in ionic compound? So Y is having a charge valency plus 2, so group 2 element, that is D. Question 18. The graph shows the second ionization energy for the element. So second ionization energy, and which could be lithium. How we can work out this? Because lithium, it is 3 and 7, so it is have the electronic configuration of lithium is 1s2 and 2s1. So when we remove one of the electron and we are left with 1s2, we have to remove second electron from this one. So this is inert gas configuration, so lithium should have the highest value for ionization energy, second ionization, so B is the right answer. In question 19, the first 5 ionization energy in kilojoule per mole for aluminium are given. The orbital from which the first 5 electrons are removed. So aluminium is 13 and 27. So when we write electronic configuration, it is 1s2, 2s2, 2p6, 3s2, 3p1. So when we remove the electron is always removed from last shell. So we remove from 3p, then 3s, then 3s, then 2p, then 2p. So it should be 3p, then 3s, then 3s, 2p, and 2p. So D is the right answer. Going across the periodic table from sodium to aluminium, what we will observe, the melting temperature increase, that's true. So A is the right answer. The radius increase, that's wrong. It decreases. The radius of a metal ion also decreases. The bonding of element changes. It remains metallic from sodium to aluminium. So A is the right answer. Question 21. The graph below represent the successive ionization energies for element X against the electron removed. X is not a symbol of the element. So how we can work out, if these are the last shell electrons, and then 1, 2, 3, 4, 5, they're comparable. So this is another shell. So how many electrons are there in the last shell? Total 3 electrons. And even why there's a difference here, that difference is due to orbital. Like if there is a change in orbital, like if one electron removed from 3p, another removed from 3s, then there will be a difference. But so basically one electron removed from 3s, then two of the electron are removed from 3p, or one of the electron removed from 2p and then removed from 2s. But we have more 8 electrons here. 1, 2, 3, 4, 5, 6, 7 electrons there. So it means in the lower shell it is having more electron. So last shell it is having 3 electrons. This belongs to group 3. From the graph it is possible to deduce the most stable. So because it is group 3, so it will form X 3 plus or plus 3. Question 22. The relative atomic mass of element is determined by using a mass spectrometer. Define the term relative atomic mass. So the definition of relative atomic mass, it is a mass of element which is compared with 1 by 12 mass of an atom compared with carbon 12, or average mass of an element compared with carbon 12. 1 by 12 part of carbon 12. The mass spectrum of rubidium is shown below. Explain why there are two peaks in the spectrum. So why there are two peaks in the spectrum? It shows that it has two isotopes. Using the spectrum, calculate the relative atomic mass. So how we can calculate the relative atomic mass? The mass multiplied by percentage, so that it's 72, and this will be 28. So when we calculate, this will be 85 multiplied by 72 plus 87 multiplied by 28, and that divided by 100. So we'll get the mass, the average mass of the two isotopes of rubidium, which will come out as 85.56 if we write to two decimal places. Gram per mole, or atomic mass unit. Question 23. Which changes atomization? Atomization means when we form 1 mole of a gaseous atom from the element. So D is the right answer. Which group the element belongs to? So when we check 789, 1500, 3000, 4000, then there's a big jump, 16,000. So it means it is having 4 electrons in the outermost shell. So it belongs to group 4. State how the following processes are achieved in a mass spectrometer. Ionization of the sample. So how we ionize the sample? So we target the sample by high energy electron or bombarded with high energy electron. Acceleration of the ion. How we accelerate the ion? By using electric field. How we deflect the ion? By using a magnetic field perpendicular to the motion of the particle. State how we can find the molecular mass of a substance from its mass spectrum. So the mass to charge ratio multiplied by charge, or the molecular ion which we'll get multiplied by the charge, we will get the mass of the heat. So molecular ion multiplied by the charge will get the mass of this isotope or molecular mass. In recent years, a particular linen cloth was shown using a mass spectrometer to have been made from a flax grown in early 14th century. Suggests how a mass spectrometer can be used to estimate the age of the cloth. So what we can do, we can identify or determine amount of or abundance of carbon 14 and compare use the half-life of carbon 14, find the abundance of carbon 14 and use a half-life of carbon 14. We can determine the age of cloth. Next question. An isotope of an element, atomic number Z, has a mass number Z, 2Z plus 4. How many neutrons are there? So how to find a number of neutrons? So take a difference, because the element is there, which is 2, the mass number 2Z plus 4, atomic number Z. So basically it is 2Z atomic mass, the mass number, minus the atomic number, so it will be Z plus 4, so A is the right answer. When aluminium is plus 4 ion form, the fourth electron is lost or removed from which, so it is 1s2, 2s2, 2p6, 3s2, and because aluminium is 13, so 10 and 3p3. So we remove 3 electrons from one from first 3p, then 2s, then 2s, then 3s, 3s, and then 2p. So 3 is the right answer. Question 28. Hydrogen has 3 isotopes. In terms of subatomic, give a similarity and the difference. So they will have same protons and they will have different neutrons inside the nucleus. When nitrogen atoms collided, a high energy neutron, it's one atom of tritium and one atom other element is formed. Complete the equation. So atomic number should be 6 because 1 is already there. Total 7 down, so it should be 6 plus 1, 7. And the mass here 15, 3 is already used, so this should be 12, so it will form carbon 12. Deuterium gas consists of a molecule each contain one deuterium atom and one tritium. Is used in some nuclear warhead. Typically, each warhead has about 4 grams of gas added. Calculate the number of moles of tritium deuterium in 4 grams. So how we can work out the total number of the moles? Moles equal mass in gram divided by molar mass. So because it contains deuterium and tritium, so it is 2 and 3. So total mass of this gas of hydrogen, which is having the isotope, that will be 5. So moles equal mass in gram divided by molar mass. So we get 4 by 5, which is 0.8. Calculate the volume in cm cube. So volume in cm cube, moles equal volume in dm cube divided by 24, or volume in cm cube divided by 24,000. So mole multiplied by 24,000 will get the volume in cm cube. So moles are 0.8 multiplied by 24,000 will get the volume of this gas in cm cube, which will come out as 19,200 cm cube. Tritium is not usually included in calculation for relative atomic mass of hydrogen because it is radioactive and has relatively short half-life. Calculate the relative atomic mass of hydrogen. So how we calculate the relative atomic mass of mass, which is 1.0078 multiplied by percentage 99.9850 plus the mass, which is 2.0141 multiplied by abundance 0.0150 and divided by 100. This will come out as 1.007951, or the mass was given to 4 decimal place, so we can round it off 1.0080. That will be the mass. Mark on the energy level diagram with an arrow transition that represent the ionization of hydrogen. The term ionization here refers to when electron is removed from the atom. We call that as ionization. So for hydrogen, electron is in the first shell and we supply energy, so the electron is removed. Infinity means it's outside the atom. So that arrow is showing the ionization energy. In some versions of periodic table, hydrogen is placed in same group as sodium. Give the electronic configuration for both hydrogen atom and for sodium atom using sp notation. Use electronic configuration to suggest why this is reasonable. So when we write hydrogen is having only one electron, so it is only 1s1, and for sodium, which is 11 and 23, so it is 1s2, 2s2, 2p6 and 3s1. So you can clearly see that the last shell is an s orbital. Why they? That's why they are in place in the same group, as both are s block element and having the same number of electron in the last shell. Which element in the periodic table has the highest first ionization, and justify your answer. So which element in the periodic table is having the highest first ionization? That's helium. And what is the reason why helium is having the highest? Because it is 1s2 and there are 2 protons and 2 electrons. In case of hydrogen, there is 1 proton and 1 electron, and the configuration is 1s1. But in case of helium, why it is having the highest first ionization energy? Because the electrons are in the first shell, so electron we want to remove are very close to the nucleus, and there is no or little shielding effect. Why no shielding effect? Because the shielding effect refers to if the number of electrons, how many electrons are before that. So there is no or very little shielding effect is there, and there is a greater nuclear charge. It's of 3 marks. So how you write the answer? Number 1, you will mention there's a greater nuclear charge. Electrons are closer to the nucleus. And does not have any shielding effect. These are the reasons that helium is having the highest ion. Even though hydrogen does not have shielding effect, but the charge on hydrogen is only 1 proton, whereas for helium it is 2. And the size, when we move across the period, the hydrogen size is larger as compared to that of helium, which is having 2 protons and 2 electrons, because a stronger attraction is there, which reduces the size of the orbital. Which of the following eye could be deflected least in a mass spectrum? So the value, the deflection, lighter deflect most and the heavy one deflect the least. In terms of mass to charge, so the one which will have the smallest value of mass to charge, it will deflect more. The one which will have higher value of mass to charge, it will deflect less. So when we write the mass to charge ratio, like chlorine 35 is there. So 35 divided by 2 divided by 1, so this will be 35. This will be 37 divided by 2, so that's equal to 16.5. Yeah, sorry, 18.5. Yeah, that's 16.5. The other one is 18.5. So 35 divided by 1, same thing, 35 divided by 2 and 17.5. This will be 37 divided by 1, so 37, and this will be 37 divided by 2 equal to 18.5. So the one which is having the highest value, that's C, so C is the right answer. In a mass spectrometer, a positive ions are accelerated. How we accelerate the positive ion? By applying electric field, so passing them between the charge plate, or by applying electric field. By bombarding with a fast moving electron, that is causing an ionization. And passing through a magnetic field, that causes a deflection. The number of unpaired electron in nitrogen atom in a ground state, so when we write the nitrogen is 7, so it is 1s2, 2s2, 2p3. So when we write show electron in a box model, there is a pair, and 2p. Singly, first they will occupy, so 3 unpaired electrons are there, so D is the right answer for this. Question 32. The mass spectrum of element is shown below. The relative atomic mass of the element, so relative atomic mass is percentage multiplied by mass. So the relative abundance 60 multiplied by 69 plus 71 multiplied by 40 divided by 100. So for question 32, it will come out as B, so 69.8. Four sequences of ionization energies of elements in kilojoule per mole are shown in below. The sequence giving the first ionization element going down the group. So going down the group, ionization energy decreases because the size increase, number of shells increases, so ionization energy will decrease. So which order is showing the decrease in ionization energy? So B is representing the decreases. So that's why B is the right answer. The sequence which show first 5 ionization energy of calcium. So first 5 ionization energy of calcium, calcium is 20. So the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 1s2, 2s2, 2p6, 3s2, 3p6 and that's make 20. So we remove electron from 4s. So first two should be closer and then there should be a big jump between second and third. So first two should be closer and there should be a big jump. So 590 approximately double and then it becomes 5000. So first two are closer and then there is a big jump. So it means A is the right answer for this. The sequence showing the first ionization energy of successive elements, atomic number increases by 1 starting for group 6. So group 6, 7, 8, so it should increase and then from it will be 1 and 2 because they are asking for successive. So again it should for first three numbers it should be same and then there should be a difference like decrease and then difference. So 1000, 1200, 1500 and then there is a decrease. So it means it's group 1 and 2. So C is the right answer for this question. Is it clear? Question 34. This question is about some of elements in period 3. So silicon is given. It's when we check the periodic table, it is 14 uh, protons, 14 electrons are there, neutron 20, 14 minus 29 or 29 minus 14 basically. That's equal to 15. Complete the electronic configuration. So 1s2, 2s2, 2p6, 3s2 and 3p. We have to arrange 14, so 10 and 3p2 will be there. Explain why. Explain the following, referring the difference in the structure and bonding. Silicon is having a higher temperature than phosphorus. Why? Because silicon it formed four bonds, or it tend to form a macromolecule, a giant structure, where phosphorus is a simple molecular structure. So silicon will have stronger attraction compared to that of phosphorus. So silicon is a giant covalent, whereas phosphorus is a simple molecular. That's why they have the difference. Silicon form four bonds and greater number of bonds must be broken to change the state as compared to that of phosphorus. That's why it will have the high melting point. Magnesium has a higher melting temperature than sodium. So both are metallic bond, but magnesium ion is smaller in size as compared to that of sodium ion. And magnesium is having charge plus 2, where sodium is having a charge plus 1. So when you write the answer, you will mention that magnesium atom or ions are smaller compared to that of sodium, and magnesium is having a greater charge and more electrons in the structure as compared to that of sodium. Suggest why the atomic radius decreases when we move across the period. So when we move across the period, why the atomic radius decreases? Because there is an increase in nuclear charge. So the nuclear charge increases. There are more protons are there, or increase in nuclear charge for the same shielding effect, or for the same outermost electron in the outermost shell. That's why the size decreases. So nuclear charge increase and same shielding effect or same electrons in the same shell, which causes the decrease in size of the atom. At room temperature, silicon tetrachloride is liquid that does not conduct electricity. Draw a dot and cross diagram for silicon. So silicon belongs to group 4, so it will share 4 electrons. Chlorine belongs to group 7, it will share 1, and there will be 6 unshared electrons for chlorine. The diagram shows the values of first ionization energy for sodium. Yeah, tetrahedral, it will be tetrahedral, but we just need a dot and cross diagram. So in dot and cross diagram, we don't have to represent the bond angle. If they say draw the structure and show the bond angle, then you will represent the values for first ionization of sodium and magnesium is there. Justify, then on the diagram, add a cross mark the approximate position for values for aluminum and silicon. So aluminum, it will be between magnesium and sodium. Why? Because aluminum we remove electron from 2p orbital as compared to magnesium, and it will have more shielding effect, so it can easily remove electrons. So smaller changes there, and silicon it will be higher than of magnesium. Justify your suggested value in terms of atomic structure and configuration of the element. So why we mark aluminum below, between, and why we mark silicon at a higher position. So aluminum, because electron is removed from 3p orbital, so which is further away from the nucleus, and it will have greater shielding effect. And if it is a greater shielding effect, it will have lower ionization energy. And for silicon, it has more protons or greater nuclear charge compared to aluminium. So even removed from the same shell, but because greater nuclear charge, that is why it will. Regarding the size, no, because they mention in the question using the term orbital. So you don't have to mention the size, you have to use the term orbital to explain the answer, as they mention that in terms of atomic structure and electronic configuration. So rather than only the size, you should use the electronic structure as well. In question 35, which of the following graph not drawn to scale best represent the trend in melting point? So for first fourth group it increases and then it decreases. So for 35, A is the right answer. So this was the assignment related to mass spectrum and ionization energy. Any question related to the class today? So I'll end the session and share this with you.